Dear children, you might have seen beams of light from the headlamps of scooters, cars, and engines of trains. Similarly, a beam of light can be seen from a torch or searchlight from a lighthouse or from an airport tower. What do these experiences suggest? From these, we can conclude that the light travels in a straight line path. Do you remember the activity performed in class 6th? That is, if you look a lighted candle through a straight pipe with one eye, you can see the light of candle flame. On the other hand, if you look at the lighted candle through a bent pipe in similar way, you will not see the light of candle flame. This means that light of candle flame can travel through the straight line path. How can we change the path of light? Do you know what happens when light falls on a polished or shiny surface? One way to change the direction of light is to let it fall on a shiny surface. For example, a shiny stainless steel plate or a shining steel spoon can change the direction of light. The surface of water can also act like a mirror and change the path of light. That is, when light falls on the surface of an object, the object sends the light back. The process of sending back the rays of light which fall on the surface of an object is called reflection of light. Ray of light which falls on an object is called incident ray, and the ray of light which is sent back by an object is called a reflected ray. We can see the objects around us because they reflect light received from a luminous object into our eyes. For example, we can see a table lying in a room because it reflects light falling on it in all the directions, and that light may be from the sun or artificial light. We can see the image of our face in a mirror because the smooth and shiny surface of mirror produces a regular reflection of light. We cannot see the image of our face in a sheet of paper because the rough and dull surface of paper produces irregular reflection of light. There are two types of images that can be formed with light. That are real images and virtual images. In a cinema hall, we can see the images of actors and actresses on the screen. That is, the image which can be obtained on a screen is called a real image. The image of our face formed by a plane mirror cannot be received on a screen. It can be seen only by looking into the mirror. So the image which cannot be obtained on a screen is called a virtual image. A virtual image can be seen only by looking into a mirror. Our image in a plane mirror is an example of virtual image. When you see your image in a plane mirror, is it exactly like you? Have you ever noticed that there is one interesting difference between you and your image in a mirror? Let us find out. Stand in front of a plane mirror and look at your image. Raise your left hand. Which hand does your image raise? Now touch your right ear. Which ear does your hand touch in your image? Observe carefully. You will find that in the mirror, the right appears left and the left appears right. Please note that only sides are interchanged. The image does not appear upside down. Now, write down your name on a piece of paper and hold it in front of a plain mirror. How does it appear in the mirror, children? Can you now understand why the word ambulance is written as in the slide? When the driver of a vehicle ahead of an ambulance looks in his rear view mirror, she or he can read ambulance written on it and give way to it. It is the duty of every one of us to allow an ambulance to pass without blocking its way. This effect of reversing the sides of an object and its image is called lateral inversion. And we say that the image formed in a plane mirror is laterally inverted. This is what the right side of our body becomes the left side in the image, whereas left side of our body becomes right side in the image. Okay? Let us study the characteristics of the images formed by a plane mirror. The image formed in a plane mirror is behind the mirror. It is virtual, that means it cannot be obtained on a screen. The image in a plane mirror is of the same size as the object. The image in a plane mirror is erect and it is laterally inverted. The image formed in a plane mirror is at the same distance behind the mirror as the object is in front of it. Let us see spherical mirrors. A spherical mirror is that mirror whose reflecting surface is the part of a hollow sphere of glass. The spherical mirrors are of two types, concave mirror and a convex mirror. A concave mirror is that spherical mirror in which the reflection of light takes place at the concave surface. Convex mirror is that spherical mirror in which the reflecting surface takes place at the convex surface. See children, a shining steel spoon represents both a concave as well as convex mirror. The front side of a spoon is bent inward. So the front side of shining spoon represents concave mirror. The back side of a spoon is bulging outward. So the back side of the shining spoon represents a convex mirror. Okay. A concave mirror is a converging mirror. The concave mirror reflects the parallel rays of light in such a way that after reflection, all the rays converge or meet at one point called a focus in front of the mirror. The focus of a concave mirror is a point in front of the mirror at which parallel rays of light converging after reflection from the concave mirror. The distance from the focus up to the concave mirror is called focal length of the concave mirror. Concave mirror is also known as a converging mirror. When a beam of parallel rays falls on a convex mirror, after reflection from the convex mirror, the parallel rays of the light are spreading out or going away from one another. That is, when parallel rays of light spread out, we say that the rays of light are diverging. So, convex mirror is a diverging mirror. Focus of a convex mirror is a point behind the mirror from which the parallel rays of light falling on convex mirror appear to diverge after reflection from convex mirror. So, a convex mirror is also known as a diverging mirror. Now, see the uses of concave mirrors. Concave mirrors are used as shaving mirrors to see a large image of the face. And concave mirrors are used by the dentist to see the large images of teeth of patients. Concave mirrors are used as reflectors in torch, headlights of vehicles such as cars, scooter, buses, etc., and searchlight to get a strong straight beam of light. Next, uses of convex mirrors. Convex mirrors are used as rear view mirrors or side view mirrors in vehicles, buses, trucks, etc. to see the traffic at the rear side. Rear side means the back side on the road. Big convex mirrors are used as shop security mirrors. Next, spherical lenses. A lens is a piece of transparent glass bound by two spherical surfaces. Lenses play a very important role in our everyday life. The magnifying glass, which is used to see very small things clearly, is a type of lens. Lenses are used in making spectacles, cameras, microscopes, telescopes, film projectors, and binoculars, etc. Lenses are of two types, convex lens and a concave lens. Lens which is thicker in the middle than at the edges is called a convex lens. The lens which is thinner in the middle than at the edges is called a concave lens. A convex lens is a converging lens. When a beam of parallel rays of light falls on a convex lens, the light rays converges to one point called a focus. The focus of a convex lens is a point where parallel rays of light converging after passing through the convex lens. The distance from the focus up to the center of a convex lens is called a focal length of convex lens. A convex lens is a converging lens. Before we discussed, a concave mirror also converges rays of light. In this respect, a convex lens is similar to a concave mirror. Concave lens is a diverging lens. Suppose a beam of parallel rays of light falls on a concave lens. We can see that after passing through the concave lens, the rays of light are diverging, that is, spreading out. The focus of a concave lens is a point from which the parallel rays of light appear to diverge after passing through the concave lens. The distance from focus up to the center of concave lens is called focal length of concave lens. Thus, a concave lens is a diverging lens. In this respect, a concave lens is similar to a convex mirror. This is because a convex mirror also diverges rays of light. Next, the uses of convex lens. Convex lenses are used as magnifying glasses. They are used in making spectacles, cameras, microscopes, telescopes, and binoculars, etc. Next, uses of concave lenses. Concave lenses are used in making spectacles. Concave lenses are used in making certain kinds of telescopes. They are also used in peepholes in the doors of hotel rooms to see the image of the person standing outside. Dear children, have you ever seen a rainbow in the sky? You might have noticed that it appears usually after the rain when the sun is low in the sky. The rainbow is seen as a large arc in the sky with many colors. How many colors are present in a rainbow? When observed carefully, there are 7 colors in a rainbow. Though it may not be easy to distinguish all of them, these are red, orange, yellow, green, blue, indigo and violet. You might have seen that when you blow soap bubbles, they appear colorful. Similarly, when light is reflected from the surface of a compact disc, you see many colors. On the basis of these experiences, we can say that sunlight is a mixture of different colors. When a beam of white light is passed through a glass prism, a band of 7 colors formed on a white screen. The splitting of white light into 7 colors on passing through a transparent medium like a glass prism is called dispersion of light. The formation of spectrum of 7 colors shows that white light is a mixture of 7 colors. The rainbow is an arch of 7 colors seen in the sky. It is produced by the dispersion of sunlight by tiny raindrops suspended in the atmosphere. The formation of rainbow having 7 colors shows that white sunlight consists of 7 colors. Thus, a rainbow is a spectrum of sunlight. In the year 1665, Isaac Newton discovered by his experiments with the glass prisms that white light consists of a mixture of light of 7 colors. Newton found that if a beam of white light is passed through a glass prism, the white light splits to form a band of 7 colors on a white screen. I have just studied that white light consists of 7 colors. An important question now arises. Can we mix these 7 colors to get white light? Yes, we can mix 7 colored lights to back white light. Take a circular cardboard disc of about 10 cm diameter. Divide this disc into 7 equal segments. Paint the 7 colors of white light like red, orange, yellow, green, blue, indigo and violet on these segments. Instead of painting the segments, we can also paste 7 colored papers on these disc. The disc painted with the 7 colors of spectrum is called Newton's disc. Make a small hole at the center of the disc and rotate freely. When the disc is rotated very fast, all the 7 colors mix together, due to which the disc appears to be white. The rapid rotation of Newton's color disc tells us that mixing of 7 colors of the spectrum can give us white light. Okay.